In this video, we are going to work through atomic structure and isotope problems with a focus on the why. You will learn how to identify protons, neutrons, and electrons, why isotopes behave identically chemically despite their mass differences, how to calculate weighted average atomic masses, and how to determine electron counts in charged ions. These are high-yield concepts. Mastering them now will secure easy points on your first exam and build the intuition you need for the harder topics later. I have broken these down into 4 clear categories. For each one, we will set it up logically, use the periodic table as our map, and verify that our answer makes physical sense. So grab your calculator, pause when you need to, and let's get started. Category 1 is protons, neutrons, and electrons. Before solving these problems, we need to lock in 3 fundamental rules that define every atom in the universe. Number 1, the atomic number Z acts as the atom's identity card. It tells you the number of protons in the nucleus. If the number of protons changes, the element changes. We can find the atomic number on the periodic table. It'll be the top value found in a box for an element. Number 2, electrical neutrality. Atoms are neutral by default. This means the positive charge from the protons must be perfectly balanced by the negative charge from the electrons. Therefore, in a neutral atom, protons equal electrons. If there is a charge for an element, we can calculate the number of protons or electrons with the equation charge equals protons minus electrons. Number 3. The mass number A is the total count of particles in the nucleus and is equal to protons plus neutrons. We ignore electrons here because their mass is so tiny, it is negligible for these calculations. Only protons and neutrons contribute to the mass for an atom. All of these come together in the chemical symbol. We have mass number A on the top, atomic number Z on the bottom, next to the chemical symbol, and the charge is at the top right. Question 1. How many protons, neutrons, and electrons are in aluminum-27? First, find aluminum on the periodic table. It has an atomic number of 13. This is a non-negotiable fact for aluminum. It means every aluminum atom has 13 protons. Because the problem states this is a neutral atom, the positive and negative charges must balance. So if we have 13 positive protons, we must also have 13 negative electrons. Finally, we look at the mass number. The notation aluminum-27 tells us the mass number is 27. Since the mass number is the sum of protons and neutrons, we can find the neutrons by subtracting the proton count from the total mass. 27 minus 13 equals 14 neutrons, so aluminum-27 has 13 protons, 14 neutrons, and 13 electrons. Question 2. Determine the subatomic particles in oxygen-16. Locate oxygen on the periodic table. Its atomic number is 8, which tells us immediately that it has 8 protons. This defines the element. Since the atom is neutral, the positive nuclear charge is cancelled out by the electron cloud. Therefore, there are also 8 electrons. For the neutrons, we use the mass number provided, 16. We take the total mass of 16 and subtract the 8 protons. 16 minus 8 gives us 8 neutrons. Oxygen-16 consists of 8 protons, 8 neutrons, and 8 electrons. Question 3. How many electrons are in a neutral atom of phosphorus? Find phosphorus on the periodic table. Its atomic number is 15. This means the nucleus contains 15 protons. The keyword here is neutral. In chemistry, neutral implies a net charge of 0. To cancel out the plus 15 charge from the nucleus, the atom requires a minus 15 charge from the electron cloud. Therefore, a neutral phosphorus atom must have 15 electrons. Question 4. What is the atomic number and mass number of lithium-6? The atomic number is found on the periodic table. For lithium, that number is 3. This tells us there are 3 protons. The mass number is often confused with the atomic mass, but here it is explicitly given in the name lithium-6. This means the total count of protons and neutrons is 6. So lithium-6 has a mass number of 6 and an atomic number of 3. Category 2 is isotopes and mass number, and now that we understand the basics, let's talk about isotopes. The word isotope comes from Greek meaning same place. They occupy the same place on the periodic table because they are the same element. The key concept is isotopes have the same number of protons, so they are the same element, but a different number of neutrons, so they have different masses. Crucially, because they have the same number of electrons and protons, isotopes exhibit the exact same chemical behavior. Your body, for example, cannot tell the difference between carbon-12 and carbon-13 chemically. It uses them both to build cells exactly the same way. Question 5. What are the two naturally occurring isotopes of chlorine, and what are their mass numbers? Chlorine exists primarily as chlorine-35 and chlorine-37. Both are chlorine, so both must have an atomic number of 17, meaning 17 protons. The difference is in the nucleus. Chlorine-35 has a mass number of 35. If you subtract the 17 protons, you get 18 neutrons. Chlorine-37 has a mass number of 37. Subtracting 17 protons gives you 20 neutrons. Same protons, different neutrons. Question 6. An atom has 20 protons and 22 neutrons. What is its mass number? The mass number is simply the count of nucleons, or particles in the nucleus. We add together the protons and the neutrons to get the mass number. 20 protons plus 22 neutrons equals 42. The mass number is 42. By the way, with 20 protons, this element is calcium, so this would be the isotope calcium-42. Question 7. Define isotope and give two examples. An isotope is a variant of a chemical element that has the same proton count but a different neutron count. Isotopes have the same atomic number but different mass numbers. This also means they have the same number of protons but a different number of neutrons. Common examples include carbon-12, which has 6 neutrons, and carbon-14, which has 8 neutrons, and also uranium-235 and uranium-238. They are both uranium, so they both have 92 protons, but they have different mass numbers. Uranium-235 has 143 neutrons, and uranium-238 has 146 neutrons. Same number of protons, but a different number of neutrons. Question 8. How do isotopes differ from each other? Strictly speaking, isotopes differ only in their mass and their nuclear stability. They contain different numbers of neutrons. This changes their mass number, but, and this is the most important part for your exams, it does not change their electron configuration or their chemical reactivity. They have the same number of protons, so they are the same element. Category 3 is average atomic mass calculations. This is where students often get confused. You might ask, if protons and neutrons are whole numbers, why is the mass of carbon on the periodic table 12.011? The number on the periodic table is the average atomic mass. It is a weighted average of all the isotopes that exist in nature. It's exactly like calculating your grade in a class where tests are worth 60% and homework is worth 40%. You can't just average the two numbers, you have to weight them by their importance, or in this case, their abundance. The formula to calculate average atomic mass will be average mass equals mass of isotope 1 times abundance 1 plus mass of isotope 2 times abundance 2, and so on. Note, always convert percentages to decimals by moving the decimal point 2 places to the left for the abundance of the isotopes. Question 9. Calculate the average atomic mass of chlorine. Chlorine-35 has a mass of 34.97 AMU and an abundance of 75.78%. Chlorine-37 has a mass of 36.97 AMU and an abundance of 24.22%. First, convert percentages to decimals by dividing each percentage by 100. 75.78% becomes 0.7578. 24.22% becomes 0.2422. Now, set up the calculation by multiplying the decimal abundance by the isotope mass and adding all values together. 34.97 times 0.7578 plus 36.97 times 0.2422. The first part equals 26.49, The second part equals 8.95. Adding them together gives 35.45 atomic mass units. Notice how the answer is much closer to 35 than 37? That makes physical sense because the lighter isotope is much more abundant. The isotope with the mass number that is closest to the average atomic mass is the most abundant isotope in nature. Question 10. Find the average atomic mass of boron. Boron 10, 19.9%. Boron 11, 80.1%. First, convert percentages to decimals by dividing each percentage by 100. 19.9% becomes 0.199, and 80.1% becomes 0.801. Now set up the calculation by multiplying the decimal abundance by the isotope mass and adding all values together. 10 times 0.199 plus 11 times 0.801. This simplifies to 1.99 plus 8.81. The sum is 10.80 atomic mass units. Again, check your logic. The answer is very close to 11, which makes sense because boron 11 is 80% of the sample. The isotope with the mass number that is closest to the average atomic mass is the most abundant isotope in nature. So boron 11 is the most abundant isotope in nature. Question 11. Calculate the weighted average mass of magnesium. Magnesium 24, 78.7%. Magnesium 25, 10.1%. Magnesium 26, 11.2%. First, convert percentages to decimals by dividing each percentage by 100. 78.7% becomes 0.787, 10.1% becomes 0.101, and 11.2% becomes 0.112. Now, set up the calculation by multiplying the decimal abundance by the isotope mass and adding all values together. 24 times 0.787 plus 25 times 0.101 plus 26 times 0.112. Add these values together, 18.89 plus 2.53 plus 2.91. The result is 24.33 atomic mass units. Category 4 is ions, cations, and anions. In chemical reactions, the nucleus, protons, and neutrons remain safe and untouched deep in the center of the atom. All the action happens at the surface. With the valence electrons, when an atom gains or loses electrons, it becomes an ion. Cations are positive because they have lost negative electrons. Think positive like a cat. And ions are negative because they have gained negative electrons. We can also calculate the charge with the equation charge equals protons minus electrons. Question 12. How many electrons are in a magnesium 2+ ion? Magnesium has an atomic number of 12, so a neutral atom starts with 12 protons and 12 electrons. The charge is +2. A positive charge indicates a loss of negative charge and a loss of electrons, so we take the starting 12 electrons and subtract 2. 12 minus 2 equals 10 electrons. We can also calculate the number of electrons with the equation charge equals protons minus electrons, plus 2 equals 12 protons minus electrons. 12 minus 2 equals 10 electrons. Question 13. What is the charge on an ion with 17 protons and 18 electrons? Compare the positives and negatives. Protons plus 17. Electrons minus 18. 17 minus 18 equals -1. This is a chloride ion with a 1- charge. We can also calculate the charge with the equation charge equals protons minus electrons. 17 protons minus 18 electrons equals -1. Question 14. Determine the number of electrons in a nitride 3- ion. Nitrogen has an atomic number of 7, so a neutral nitrogen atom has 7 protons and 7 electrons. The charge is 3-. A negative charge means the atom gained electrons. So we take the original 7 electrons and add 3 more. 7 plus 3 equals 10 electrons. We can also calculate the charge with the equation charge equals protons minus electrons. -3 equals 7 protons minus electrons. This will give us 10 electrons. Question 15. Determine the number of electrons in a sodium plus 1 ion. Sodium has an atomic number of 11, so a neutral sodium atom has 11 protons and 11 electrons. The charge is plus 1. A positive charge means the atom lost electrons, so we take the original 11 electrons and subtract 1. 11 minus 1 equals 10 electrons. We can also calculate the charge with the equation charge equals protons minus electrons, plus 1 equals 11 protons minus electrons. This will give us 10 electrons. As you practice these atomic structure problems, keep this perspective in mind. You are not just crunching numbers, you are accounting for the building blocks of matter. Protons define identity. Neutrons provide nuclear glue and mass. Electrons define reactivity and charge. If you slow down, use the periodic table as your cheat sheet, and ask yourself, does this answer make physical sense? You'll ace these questions every time. Pause the video here, rework the calculations we just did without looking at the solutions, and make sure your setup is flawless.